Hi guys, welcome to Vedanta Generation. Today I have one more question for you from GATE 2016 set 1 from Electronics and Communication paper. This is a question on electromagnetic theory, and here is the question. The current density in a medium is given by J, the total current and the average current density flowing through the portion of a spherical surface. So we have to find the total current and the average current density that is flowing through the portion of a spherical surface, and the spherical surface has a radius of 0.8 meter, and the angle elevation angle theta is varying from pi by 12 to pi by 4, and the azimuth that is phi is varying from 0 to 2 pi. So that would be the whole circle, the azimuth angle. So we know that so let's just find the total current first. So we know that I is given as surface integral J dot dA, where A is the area, small area over which we have to integrate. So from this given problem, we know that it is a surface integral of J dot dA, where it is over a spherical surface, and we know that dA for a spherical surface, which is this small incremental area, can be written as dA is equal to, so I am just going to write this small incremental area of a spherical surface. So for that I will just draw a small schematic. You could either remember this or you can find out when you are where you can find out this by properly drawing the schematic, or in this case it's much easier if you know how to write this incremental area, because it will be useful for other problems if we are to use a cylindrical coordinate system. So what we have here is an axis, and we have to find a small incremental area which is dA, and this in the spherical coordinates can be given like this. So this is r, where r is the radius. Now we know that the height of this dA is given by r d theta, because the elevation angle is theta here, and the height of this small incremental area is given as, so dA equal to r d theta, and we have to find the width of this small incremental area. So the width of this small incremental area is given as r sin theta d phi. So the incremental area is r d theta, r sin theta d phi. Now let's just plug this into this equation here. So I is equal to, so since it's a surface integral, the angle theta is varying from pi by 12 to pi by 4, and again there is an integral, and phi is vary from 0 to 2 pi, and we have the j, which is 400 sin theta divided by 2 pi r square plus 4 ar, and we have this dA vector, and this is a vector actually, and it's also pointing outwards in the r direction, so the direction is ar again. So when we put this here, so dA is r d theta, r sin theta d phi, and ar. So these two are in the same direction, so the effective dot product is just 1, and what we are left with is I is going from pi by 12 to theta equal to pi by 4, and phi is going from 0 to 2 pi, and 400 sine theta divided by 2 pi r square plus 4, and there is r square theta here, and there is a d theta and d phi. So, we have to evaluate this integral to find the total current. Pi by 12 to pi by 4, that is theta varying from pi by 12 to pi by 4, and you have sine square theta d theta, and phi varying from 0 to 2 pi, it is just d phi, and you also have just the r's dependence, which can be taken out of the integral, and it's 400 r square divided by 2 pi r square plus 4. We have to integrate this value, and it is again can be simplified. It's 400.8 square, since r is 0.8, so it's 2 pi into 0.8 square plus 4, and we have this integral varying from 0 to 2 pi, and it's just d phi, so the value is 2 pi, and this integral is pi by 12 pi by 4, it's sine square theta d theta, and this 2 pi and 2 pi are cancelled. So, if I solve this, it turns out to be 55.17, and we have the integration of this sine square theta. So, the sine square theta d theta is given as 1 minus, wait, it's given as, so let's make a small draft. So, it's integration of 1 minus cos 2 theta by 2 d theta. So, it turns out to be theta by 2 minus sine 2 theta by 4. So, the integration here, if you put the value, so it's theta by 2 varying from pi by 12 to pi by 4. So, minus sine of 2 theta by 4 varying from pi by 12 to pi by 4. Okay. So, let us just dive in and solve this integral. So, what we have here is again pi by 8 minus pi by 24 and minus of sine pi by 2 by 4 minus sine, so let's just put it together, this is just 4 minus it's pi by 6. So, if we solve this, it's 55.17 minus let's just say if we multiply by 3 and 3 here, it's 24 again. So, it's 2 pi by 24, which is pi by 12, and minus sine of pi by 2 is 1, and sine of 30 is 1 by 2, that is by 4. So, this turns out to be 55.17 into pi by 12 minus 1 by 8, which turns out to be 7.54 amperes. So, the total current here which is flowing through the portion of this spherical surface is 7.54 amperes. Now the question asks to find the average current density flowing through the portion of this spherical surface. So let's just try to calculate the second part of this question. So the second part of the question asks to find the average current density. So current density flowing through the portion. So the current density flowing through the portion, let's just say the current density rho is given as I by A. So we know that from the previous solution, we know that I is 7.54 amperes, and we have to find A, which is the area. So area of this sphere, when we know that it's varying from with the elevation angle pi by 12 to pi by 4, and azimuth angle phi varying from 0 to 2 pi. So we have to find the area of this portion of the sphere. So let me just draw a schematic to better understand this part. So what we have here is sphere, and we know that we have to find a portion of the area of the portion which is covered like this. So in spherical coordinates, as we found out before, the area is this incremental area, small incremental area dA is given as r d theta r sin theta d phi. So the area which is covered by this portion of the sphere can be given as A is equal to pi by 12 to pi by 4, and phi varying from 0 to 2 pi, and the area is r square sin theta d theta d phi. So we have to evaluate this integral. So r square is 0.8 square, which is coming out of this integration, and we have 0 to 2 pi d phi, and we have pi by 12 to pi by 4 sin theta d theta. So let's just go ahead and solve this part also. So what we have here is 0.8 square into 2 pi, and we have cos of theta varying from pi by 4 to pi by 12. So if I calculate this value, I get a value of 5.16 meter square. So the current density rho is given by I by A, and we know that I is 7.54 divided by 5.16, and this turns out to be 1.46 ampere per meter square. Now we know that there is no option which gives these two answers. So I got an answer of a total current of 7.54 amperes and an average current density flowing of 1.4 ampere per meter square, and none of these options are given here. So I may be wrong in deriving this in solving this question. If I am, please point out the mistake. Otherwise, I think what I got is the right answer, and there was some mistake in the question itself. That's why they have not given this option. So thanks for watching. Please go ahead and subscribe to our channel if you want to solve more such problems, and check out the description below for books that I recommend to study electromagnetic theory.